This is the second half of a two-part course on designing landscape lighting. In the first half, we talked about creating the design, responding to the ways that a property is used, making it beautiful, and providing for security. In this course, we will discuss the technical decisions necessary to specify fixtures and draw a plan. In this part of the course, we will discuss how to draw a plan, read a photometric chart, specify fixtures, locate the transformer and properly size wire, and prepare a bill of materials. It's always a good idea to begin drawing a plan with the scale drawing of the house and yard, though exact distances are not as significant an issue as they are for irrigation. The only thing affected by distances in landscape lighting is the amount of wire required. The quick and easy way to create a scale drawing of a small to medium-sized property is to place a 200-foot long measuring tape along the curb and walk from one end to the property to the other, noting the distances of major points of interest as you walk. Include the edges of the house, driveway, trees, etc. You can then do the same thing along the side of the property to get a scale plan of the yard very quickly. Things to note in the plan include the house, especially significant architectural elements like windows, columns, and the front entryway, driveway, and sidewalks. Also note major trees or landscape features that you intend to light, and pergolas, gazebos, water features, artworks, or other potential focal points in the landscape. When indicating fixtures on the plan, note the fixture, location, the type, use the part number, and any additional installation instructions. We'll talk more about this in a moment. If you will be zoning fixtures, indicate which fixtures will be zoned together. If there are customer preferences about transformer location, be sure to note those as well. Now, choosing the right fixture for the job requires a bit more technical know-how than we covered thus far. We've been talking about the design in general terms and identified basic lighting techniques like uplighting, downlighting, and how those are used to create shadowing, grazing, silhouetting, mirroring, and other effects. But when it comes to specifying product on the design and ordering the fixtures, how do you find the right light for the job? The answer is that you'll need to read the photometric chart for the fixture and use this data to ensure that your fixture produces the right amount of light for the situation. To do so requires a basic understanding of how light works. So we'll start by talking about characteristics of light, and then use those to decipher the information that appears on the photometric chart. There are three characteristics of light that are important for landscape lighting design. Number 1. The amount of light coming from the light source, which is called luminous flux and is measured in lumens. Number 2. The illuminance, or the amount of light falling over an illuminated area, measured in lumens per square foot, or foot candles. And number 3. The reflected light that the eye perceives, which is called luminance. Let's take a moment to talk about each of these. The amount of light produced by a fixture is called luminous flux and is measured in lumens. The lumen output for each fixture is available on the fixture's specification sheet. Lumens are the measurement of light intensity that is becoming standard in the industry, but at the moment, a lot of contractors still rely on their working knowledge of the wattages and incandescent lamps to choose fixtures. This is why, in Kichler's catalog, both the lumen output and the incandescent wattage equivalent are noted. The incandescent equivalent is here for contractors unfamiliar with lumens. The lumen output is listed here. It's much better to think in terms of lumen output because the measurements are more precise. For instance, lumen output varies between colors of light. Fixtures producing warm white light have slightly different lumen outputs than those producing pure white light. A quick note on light color. Color is measured in kelvins, which is a unit of temperature. As the Kelvin goes up, the light gets more blue, which we talk about being cooler light, than the more yellow, warm light. If we compare Kichler's warm white light to the pure white light, the warm white light has the lower temperature, 2700 kelvins, and the cooler, pure white light has the higher temperature, 3000 kelvins. This makes sense when you think about a fire, where a yellow or orange flame has a lower temperature than a blue flame, despite the fact that we call blue a cool color, and yellow a warm color. Returning to lumen output, if we look more carefully at the specifications for these fixtures, Kichler fixtures 16000, 16001, and 16002, we can see that although the fixtures have the same wattage, 3 watts, they have different lumen outputs for the different temperatures of light. This variance is caused by the different diodes and phosphors used to create each fixture. The 2700 Kelvin warm white fixture produces 109 lumens, whereas the 3000 Kelvin pure white fixture produces 116 lumens. It's only a difference of about 6%, but it's helpful to know that it's there. To get a sense of how the newest Kichler LED fixtures stack up to their incandescent equivalents, here's a chart that identifies the lumen output for the pure white version of the fixture, the wattage of the LED fixture, and the wattage of the incandescent lamp with a comparable lumen output. The 116 lumen fixture uses 3 watts and is comparable to a 10-watt incandescent lamp. The 180 lumen fixture uses 4 watts and is comparable to a 20-watt incandescent lamp. The 352 lumen fixture uses 6.5 watts and is comparable to a 30-watt incandescent lamp. The 590 lumen fixture uses 13 watts and is comparable to a 50-watt incandescent lamp, and the 993 lumen fixture uses 21 watts and is comparable to a 75-watt incandescent lamp. If you do the math, you can see that the LED fixtures use only about 20 to 30% of the electricity of their incandescent cousins to produce an equivalent amount of light. The amount of light falling on a surface or an object is called illuminance and is measured in foot candles, where 1 foot candles equals 1 lumen per square foot. The light is naturally brightest near the source, where the area illuminated is smaller. So, there are more lumens per square foot and therefore more foot candles. Illuminance goes down the farther away from the light source you get because the area illuminated gets larger and there are therefore fewer lumens per square foot and fewer foot candles of illumination. When we look at the performance charts of fixtures, what they are telling us are the illuminance measurements for the different kinds of fixtures. These performance data come in 2 basic types of charts, one for path lights, step lights, deck lights, bollards, etc., and another for accent lights. A path light is mounted at a fixed height above the ground, and the chart measures the foot candle value on the ground at intervals measured from the location of the path light. Charts for bollards, deck, and step lights work the same way. The light is brightest closest to the path light, the foot candle value is high, and grows less bright the further away you move from the fixture that you get. The foot candle value goes down. That is, as the distance from the path light increases, the foot candle value decreases. For instance, this path light produces 21.2 foot candles on the ground directly under the fixture, 12.1 foot candles on the ground 1 foot away from the fixture, and 5.3 foot candles on the ground 2 feet away from the fixture, 1.56 foot candles on the ground 3 feet away from the fixture, so on and so forth. Photometric data can help you sort out differences between fixtures. Consider, for instance, these 2 path lights, which have these 2 photometric charts. The fixture on the left is smaller, and you might suppose that it produces less light than the larger fixture on the right. If we look at the photometric chart, however, we see that 2 feet away from the fixture, the smaller fixture produces greater illuminance. It produces 5.3 foot candles, as opposed to the other fixtures, 4.8 foot candles. In this case, the difference is small, but when sizing fixtures, you can save yourself the trouble of having to substitute a different fixture post-installation by ensuring that the fixtures you specify produce the right number of foot candles for the application. A foot candle is somewhat of an abstract term. To get a sense of what it means, let's have a look at some foot candle referenced values. Sunlight is 10,000 foot candles. Full daylight is 1,000 foot candles. An overcast day is about 100 foot candles. Twilight is 1 foot candle, and a full moon is also 1 foot candle. Lighting engineers recommend 5 foot candles for the illumination of sidewalks and parking lots at night. So 5 foot candles represents a parking lot level of illumination. For most landscape lighting installations, you are not aiming to create a parking lot effect. 1.5 foot candles of illuminance will subtly but visibly illuminate the edges of an object in the landscape. The place to have 5 or more foot candles of light are the critical points on paths or walkways, like turns in the path, steps, and landings, focal points, and at the base of large objects like trees, so that you achieve 1.5 foot candles of illuminance at the edges of the object. Returning to our lighting performance chart, we can now read the chart to help us choose and place a fixture with an ideal foot candle value in mind. If we want to have 5 foot candles of light on a step, it would be a good idea to place the path light within 2 feet of the edge of that step. We can see on this chart that the illumination falls off sharply between 3 and 4 feet from the fixture, so we're not going to have more than 1.5 foot candles of illuminance, much more than 3 feet from the fixture. The lighting charts for accent lights are a little different, but work in essentially the same way. Let's start by taking a quick tour of the photometric charts for Kichler's LED accent lights. In this chart, fixtures are grouped into a few basic collections, beginning with the 157 Series Design Pro LED accent and InGround fixtures, which are Kichler's original integrated LED fixtures. The next chart is for the waterproof underwater fixture. These are followed by the 160 Series Design Pro LED accent fixtures with Radiax optics, which are the newest generation of integrated LED lights. The InGround fixtures with Radiax optics, and the 120-volt LED fixtures with Radiax optics. Once you've identified the fixture you are looking for, you will note 2 measurements that change as distance from the fixture increases: foot candles and beam width. With accent lights, as the distance from the fixture increases, the area that the beam lights increases, causing the lumens to be spread out over a larger and larger area. As a result, the foot candle measurement within that area steadily decreases. If we zoom in on the photometric chart for the 16000 through the 16008 accent lights, we can see better how this works. The fixtures are identified by number. Moving down a column, the fixtures maintain the same lumen output, but the beam spread increases from 10 degrees to 60 degrees. This means that the beam width at any given distance increases as you move down the chart. So, at 24 feet from the fixture, the beam width of a 10-degree 180 lumen fixture is 6.2 feet. The beam width of a 35-degree 180 lumen fixture is 13.5 feet, and the beam width of a 60-degree 180 lumen fixture is 25.9 feet. At the same lumen output, an increasing beam spread means that the area illuminated at the same distance from the fixture increases, which in turn means that the number of foot candles of illuminance at the same distance from a fixture decreases. Returning to our chart, we see that the numbers bear this out. At 24 feet, the 10-degree fixture produces 2.5 foot candles of illuminance. The 35-degree fixture produces 0.6 foot candles of illuminance, and the 60-degree fixture produces 0.3 foot candles of illuminance. So, at the same lumen output, as the beam spread increases, foot candles decrease. Moving across the chart, the beam spread remains constant, but the lumen output increases. This has 2 major consequences. Increasing lumens over the same beam spread means an increasing number of foot candles at equal distances from the fixtures. Increasing lumen output can also result in equal foot candles over a large area at increasing distances from the fixture. Again, the photometric chart bears this out. If we consider the 10-degree spot, we see that at 24 feet from the fixture, the 116 lumen fixture produces 2.2 foot candles over a 5.4 foot beam. The 180 lumen fixtures produces 2.5 foot candles over a 6.2 foot beam, and the 352 lumen fixtures produces 12.2 foot candles over a 4.8 foot beam. With the same beam spread at the same distance from the fixture, as the lumens go up, so do the foot candles. If we look at the 35-degree fixtures, we know that the 116 lumen fixtures produce 1 foot candle over a 9-foot beam at 16 feet from the fixture, and that the 352 lumen fixtures produces 1 foot candle over an 18-foot beam at a distance of 32 feet from the fixture. That is, within the same beam spread, as the lumens go up, you can achieve equal foot candles over a larger area at a greater distance from the fixture. We won't talk much about the specifics of luminance and how it is measured, but there are a few properties of luminance to keep in mind when making your lighting design. Because people in the landscape are not looking directly at the light source in landscape lighting, they don't actually perceive the illuminance, measured in foot candles and measured on the charts, of the fixture. Instead, they perceive the reflected light off of the surface of the objects they are illuminated. This is called luminance and is measured in candelas. The important thing for the lighting designer to keep in mind is that not all surfaces reflect light in the same way. This means that 2 surfaces with the exact same luminance might appear to be lighter or darker depending on how much light the surface reflects. That is, two surfaces with the same illuminance, the same number of foot candles of illumination, might have different luminance, a different number of candelas of luminance. If we look at the two kinds of brick in this image, we see that the white brick has greater luminance than the red brick. That is, it appears brighter, even though they receive equal amounts of light and shadow. What does this mean for your design? The thing to keep in mind is that lighter surfaces reflect more light than darker ones. Here are a few reflection factors to give you a sense about how different surfaces stack up when it comes to reflecting light. Red brick, 10 to 15%. Granite, 20 to 25%. Rough concrete, 20 to 30%. Sandstone, 20 to 40%. Limestone, 35 to 55%. And white paint, 75 to 85%. Looking at these numbers, we can note that limestone reflects about 3 times as much light as red brick, and white paint reflects about 6 times as much light as red brick. This means if you want the luminance to be the same for these 3 surfaces, that is, you want the amount of light reflected off each surface to be equal, they will need to be illuminated with 3 different quantities of foot candles. Landscape lighting designers don't spend a lot of time calculating luminance quantities, but they do attend to the surfaces that they are lighting. Using higher lumen output fixtures for brick and lower lumen output fixtures for white paint, or by using higher lumen output fixtures for trees with dark bark and lower lumen output fixtures for trees, like birches, with light bark. An incandescent landscape lighting accent has 2 components, the fixture and the lamp. The lamp refers to the incandescent Mr16 bulb that is inserted into the fixture. In this way, a single accent fixture can produce a wide range of lighting effects, depending on the lamp that is installed in it. With the introduction of integrated LED fixtures, LEDs are built into the fixture so that the separate fixtures need to be specified to achieve different lighting effects. This might sound more complicated, but it's really not. Instead of having to specify a generic fixture and a specific lamp for each light source, you now only have to specify one specific fixture. Path lights, deck lights, step lights, and bollards come in a variety of styles that can be customized to your customer's preference. A word of caution: don't give your customer the catalog and tell them to choose. Most distributors carry the most popular styles in stock and have to special order the rest. It's usually best to show a customer 2 styles that the distributor stocks and allow them to choose between the 2. They feel like they've contributed to the style of their installation, and you won't have to worry about the headache of special ordering fixtures. For the customer with discerning taste, a wider variety might be appealing. Just be sure to let them know up front about longer lead times and potentially higher costs, especially if they want an unusual fixture installed, say, tomorrow. There are a few style options with the more utilitarian wall wash, accent, or InGround lights, but the decision about these fixtures is mostly based on performance. Accent lights differ exclusively in terms of performance, so the choice of fixture is determined by how much light you need, over how large an area, how far away. There are, however, a number of options that you can add to fixtures to solve different lighting problems. These include cowls in a variety of shapes and sizes to shield the light source from a viewing location where glare is an issue. Honeycomb louvers to help with glare issues when the surface of the fixture can be seen either from the side or at eye level with the viewer. Frosted lenses that soften light and create a more subdued lighting effect. They can be especially useful on walls without texture to reduce harsh lines created by fixtures without a lens. Colored lenses can be used to amplify the colors in a landscape. Amber lenses create a warmer ambience, and blue or green lenses can bring out the greens in the foliage. Rock guards protect in-ground fixtures from damage. All fixtures come in a variety of finishes. The popularity of different finishes varies somewhat from region to region, so talk to your distributor to determine what they have in stock and what's popular in your area. When creating uplighting effects, you will usually use accent lights, wall wash lights, or in-ground lights. Here are some considerations for choosing the right one for the job. Accent lights have relatively narrower beam spreads than wall wash lights, and are used mostly for illuminating plant material, architectural features, and small areas on the walls of a house. Wall wash lights are best used on larger stretches of a wall. A wall without windows or the walls of entryways of gated communities are good examples, because they have a wider beam spread and illuminate a larger horizontal area than accent lights. In-ground lights are often used in situations where accent lights might be damaged, or where you need to keep the fixture out of view. for aesthetic reasons or to reduce glare. In-ground lights can be aimed just like accent lights, but don't have the range that accent lights do. They can be adjusted about 15 degrees as opposed to accent lights' 115-degree adjustment range. There are two basic types: in-ground lights that screw into the soil and those that rest in a can that is buried. You can also mount in-ground lights into concrete, sidewalks, driveways, or patios using a concrete kit. Kichler fixtures are specified using a part number that carries a number of pieces of information. For instance, part number 16003 AZT30 tells you 3 different things. The fixture type. This is an accent light with a 180 lumen output and a 10-degree beam spread. The finish. AZT indicates textured architectural bronze. And the temperature of the light, 3000 kelvins or pure white. You will quickly become familiar with the fixtures you use all the time. Pairing the right fixture with an element in the landscape or architecture means choosing the fixture with the right beam spread and lumen output for your application. There are 2 basic questions to answer which will determine the fixture best suited for the job. At the maximum distance from the fixture, how wide is the area you want to illuminate? And how bright does the light need to be? With this information, you can easily select the proper fixture based on the photometric information. Once you've decided on a fixture style or a fixture type, in-ground, accent, or 120-volt accent, use the answers to the 2 questions to choose the fixture. Now, suppose we are attempting to choose an accent light and that we'll be using the fixtures with radiax optics. If we want the beam to be 9 feet wide, 16 feet away from the fixture, we can choose the beam spread by examining the photometric data for each beam spread at 16 feet. The 35-degree beam spread is going to accomplish this. The next thing you need to know is the illuminance level at that distance. Again, most designs work with 1.5 candles of illumination at the maximum distance from the fixture. With this information in hand, find the 35-degree fixture with about 1.5 foot candles at 16 feet from the fixture. This is the 16004 fixture, which has 1.4 foot candles of illumination at 16 feet, close to our desired 1.5 foot candles. This is the basic process for arriving at the proper lumen output and beam spread of your fixtures. When specifying fixtures in the landscape, these principles, taken together with the specific considerations about the material you are lighting, will indicate a particular fixture for each specific situation. In addition to the photometric considerations, when choosing accent lights for a tree, you will also need to consider the texture of the tree's bark, its size, shape, branch pattern, and density, the color of the foliage, and whether it loses its leaves. We'll consider each of these in turn. First, bark. The 2 key variables with bark are texture and color. Ornamental trees with textured bark surfaces can create dramatic effects when grazed by accent lights. Distinctive bark colors, like the white bark of birches, are often good to highlight in a landscape lighting plan. Tree size will naturally affect the lumen output of the fixtures you are choosing. Take note, evergreen trees tend to absorb more light than deciduous trees. So, plan the number of fixtures and the lumen output of each fixture accordingly. Tree shape will affect the beam spread you choose for the application. Short, squat trees will do well with wider beam spreads than tall, skinny trees, which call for narrower beam spreads. Branch pattern and density will also affect beam spread and whether and how you choose to light the tree. This poplar, for instance, has very dense branches, so lighting it from close to the trunk means that the light will disappear when it gets up to the canopy. By contrast, this crepe myrtle has a tall trunk and open branch structure, or, in this case, palm structure, that will do well with more focused lighting. The color of foliage can affect the use of lenses in lighting. Green or amber lenses can make green foliage really pop, and pure white lights will enhance red or purple foliage. Whether a tree loses its leaves will affect how much emphasis you want to give the canopy. The branches of a bare tree in the winter can be very dramatic and beautiful, so lighting the trunk and branches of tree that lose their leaves is often the best way to go. By contrast, it's the foliage of evergreen trees that is the focal point, so spreading the light over the surface of the canopy is the best choice in that case. One of the biggest mistakes first-time designers make is to underlight elements of the landscape. trees almost always need 2 fixtures and a cross-lighting treatment. Let's consider a few examples to see how these considerations play out. First, suppose that we are going to light a coniferous tree that is 16 feet tall and has an 8-foot diameter at the base. What fixtures should we use to light this tree, and where should they be placed? A medium-sized tree like this is best lit from the outside, and we'll place 2 fixtures on either side of the tree for a cross-lighting effect. What beam spread should we choose? With a tree like this, we'll want the widest possible beam spread so that as much as the tree as possible is illuminated. We can see that a 10-degree beam and a 35-degree beam both leave a dark area in the center, which makes it somewhat difficult to see. The 60-degree beam illuminates much of the face of the tree, making it easy to pick out as an evergreen from a distance. Now that we've chosen our beam spread visually, let's figure out what lumen output we need. The top of the tree is 16 feet from the fixture. We need a beam spread of about 16 feet to cover the whole tree, and we want 1.5 foot candles at the top of the tree. With this information in hand, we can consult our photometric chart. Glancing at the photometric data, 16 feet from the fixture, the photometric data reinforces our visual decision that the 60-degree fixture is just right for the job. It has a beam spread near 16 feet at this distance from the fixture. We can then locate the foot candle value closest to 1.5 foot candles, which belongs to the 16011 fixture. It has a lumen output of 590 lumens and will give us 1.7 foot candles at 16 feet from the fixtures. It's roughly the equivalent in lumen output and beam spread of a 50-watt, 60-degree incandescent Mr16 lamp. When we draw our fixtures on the plan, we will locate them outside of the canopy and identify them with a part number. If we choose the black finish and the 3000 Kelvin temperature, the part number will be 16011 BKT30. If you want to illuminate this tree from both the front and the back, so it is visible from the house, adding a third fixture on the backside would even out the illumination on the back of the tree. Here's another example. Suppose we have a large oak tree. It's 60 feet tall and 45 feet wide and has some really amazing branches inside of it. What fixtures should we choose for this tree? Consulting the photometric data, at 60 feet from the fixture, we can see that even the 35-degree and the 60-degree beam spread fixtures with the greatest lumen output don't quite make it to our 1.5 foot candles at 60 feet from the fixture. So, if we want to get light up to the top of this tree, a 10-degree beam spread fixture is going to be the best way to go. Since the branches are so interesting, keeping the fixtures tighter to the tree and pointing them straight up to emphasize the trunk and the branches will produce the most dramatic effect. To select the proper fixture, we'll choose the fixture with the value closest to 1.5 foot candles, which in this case is the 16006 fixture. It's a 352 lumen fixture that will put 2 foot candles of illumination at the top. That's the equivalent of a 35 watt, 10-degree Mr16 incandescent lamp. We'll place these fixtures close to the tree to highlight the trunk and branches. If we choose the architectural bronze finish and the warm white version, the part number will be 16006 AZT27. Let's consider one more tree. A 12-foot tall, 10-foot wide ornamental tree. It has an open branch pattern and interesting bark texture that will do well when illuminated from close to the trunk. Consulting our photometric chart, the fixture that will give us a 10-foot beam width at 12 feet from the fixture will have a 60-degree beam spread. The chart doesn't line up exactly with the fixture, but we can see that the 16008 fixture will fall somewhere between 3.7 and 0.9 foot candles at 12 feet, and that the 16011 fixture will be over 1.7 foot candles at 12 feet. Both should work in this situation. Let's go with the 16006 in this case. If the tree was an especially important focal point in the design, the 16011 would have been the better choice. We'll plan on lighting this tree with 2 fixtures, placing one on the front and the other on the back to make the tree visible from the house. If we want the beach color and pure white light, our part number will be 16008 BE30. Specifying fixtures and drawing them on the plan works in basically the same way for other applications, so we'll discuss other situations more generally. Shrubs come in a variety of different shapes, from round to V-shaped to topiary and hedges. There are a couple of common lighting goals with shrubs, including full illumination of a shrub to create a point of interest in the landscape, to grazing of hedges used to establish rhythms. Here are some effects in the fixtures that would create them. A path light might illuminate a small shrub from above. A small 60-degree fixture, 16002 or a 16005, could be used to create a shadowing effect on a V-shaped shrub with an open branch structure. A wall wash would create a powerful silhouette effect with topiary. Small 10-degree or 35-degree accent lights, 16000 or 16001, could create nice rhythms along a hedge with grazing effects. Rocky elements in a landscape offer great opportunities to increase the variety of textures in the design. Depending on the size and shape of the rock, there are different ways to highlight these textures. Large rocks to small boulders can be illuminated from above with path lights. Large boulders, rock outcroppings, and rock walls can be grazed from below with accent lights or wall washes. And retaining walls can be illuminated using hardscape lights. Water features provide an excellent opportunity to create a focal point in your landscape that is both dynamic and dramatic. There are a few things to keep in mind when placing fixtures in and around water. First of all, make sure that any landscape lighting fixtures around pools or spas are located at least 10 feet from the water. Landscape lighting transformers are not designed for lighting within 10 feet of water that people might be swimming in. There are special underwater fixtures for reflecting pools, ponds, and other decorative water features. They are 60-degree, 150 lumen accent lights that are completely sealed within 2 layers of resin to ensure that the fixtures are completely watertight. The fixtures can be set into place and stabilized with rocks, mounted to a stainless mounting bracket, best for out-of-water use, or attaching to a weighted base to rest at the bottom of a pond or reflecting pool. When illuminating steps or stairs, there are a couple things to keep in mind. Codes vary from state to state, so make sure that you are aware of local ordinances about stair lighting. Provisions can include requiring illuminations of the top landing on a stairway, and either continuous illumination of steps through the night, the ability to control the lights from the house, or a motion detector that turns the step lights on and off when a person approaches the stairs. The main idea when illuminating steps or stairs is to provide some illumination, and there are several types of fixtures that can do this. Step lights are inserted into the steps or into the wall or vertical support next to the step. Deck lights are small down lights that can be mounted to a railing that will illuminate the steps. Hardscape lights, strip lights, or tape lights can all be affixed next to steps or underneath step ledges to provide illumination. Landscape structures like pergolas or gazebos can be excellent focal points for your landscape lighting design, and uplighting these features can create dramatic effects. But there is also an opportunity to mount accent lights at the top of these fixtures to create downlighting effects. The biggest difficulty in installing these fixtures is hiding the wires. It's a good idea to make sure that there is a location that is sufficiently out of view to run the wire up to the fixture location, or have a plan to get the wire to where you need it to be. When choosing fixtures for downlighting, make sure you don't overdo the amount of light on the ground. A 180 lumen 60-degree fixture, a 16005, will put about 1.7 foot candles onto the ground from a height of 8 feet. Unless this is a high activity area, you probably don't want much more light than that. This photograph of the Lincoln Memorial sculpture at night is a great example of how to light a sculpture in a dramatic, powerful way. Let's take a look at what makes this work so well. First off, Lincoln is cross-lit from above. This creates a focal point on Lincoln's head, shoulders, and torso where the beams cross, and consistent, although slightly less intense, illumination over the rest of the sculpture. What really makes this sculpture stand out, though, is the darkness surrounding it. The shadows that recede into the corners of the limestone building around the sculpture create a strong contrast with the strongly illuminated and highly reflective white marble sculpture. Finally, lower light on the inscription on the wall above creates a secondary focal point that, because of its significantly lower level of brightness, is clearly subordinate to the sculpture itself. How would you size fixtures to achieve this effect? The illuminance on the inscription might be 5-foot candles. It's got to be bright enough to read the text, right? The illuminance from each fixture directed at Lincoln might be 5-foot candles as well. There are multiple fixtures, which increases illuminance at the focal point where the beams cross, and the marble is more reflective than the limestone behind it. They also might be up to twice as bright, but lighting a sculpture with more than 10-foot candles can be a little too much. Illuminating a flagpole allows a customer to leave their flag on display through the night, and this can usually be done with 2 fixtures. There are regulations about the illumination of flagpoles, which give guidelines to ensure that the entire flag is illuminated at a sufficiently high level. In Kichler's catalog, there is a handy chart and guidelines that will help you specify fixtures based on the flag size and pole height. The material of the building facade is perhaps the most significant determinant when specifying fixtures. Highly textured facades like stone, brick, stucco, or even some siding often do well with grazing effects, which are achieved by accent lights. Choose your beam spread based on the available space and consider the wall height when choosing a lumen output. Again, illuminance of about 1.5-foot candles at the top of the lit area is typically specified. Less textured surfaces can be made more dramatic through shadowing effects from the landscaping in front of a wall. Less textured surfaces also do well with the softer, more even illumination of a wall wash. Remember that materials will also affect the luminance, or reflected light, visible from a position in the landscape. If you want a darker surface like brick to appear as bright as a white painted column in front of it, the brick will require significantly more illuminance than the column. When highlighting architectural features like columns, arches, and coins, those decorative stones at the corners of the brick house, select an accent light with the appropriate beam spread and foot candle value at the extremity of the architectural feature. For instance, a 10-degree spot is a good choice for a column or coins. A 35-degree medium spread might be a better choice for a small arch. 60-degree floods mounted on the roof might be the right choice for illuminating the peaks of dormer windows. We can see that the tops of the piers at the entryway of this house receive just enough light to be brighter than the encroaching twilight behind the house. Also, the spots keep the light on the piers and away from the surrounding architecture, allowing the piers to stand out against the shadows behind them. All landscape lighting projects will have a transformer. They might also have additional controls, which are usually mounted near the transformer. There are 3 main considerations when choosing a location for a transformer. Number 1, that the location is not landlocked by concrete. When choosing a location for a transformer, you need a place for the wire to get into the ground. Don't mount the transformer above a sidewalk or driveway unless you have a plan for carrying wire into the landscape. Number 2, low visibility. And number 3, the location is near an outlet. The transformer should be in a low visibility area near an outlet. There is often an outlet by the front door or on the side or back of a house. If there aren't any outlets in a good location, you will need to arrange to have an electrician install one before you install the system. It is estimated that about 50% of installations require a new outlet. Because wiring LED landscape lighting systems is so much less complex than wiring incandescent systems, many contractors do not even draw wiring runs into the plan, leaving wiring decisions up to the installer, if that is a different person. 12-gauge wire suffices for most residential systems, and because Kichler LEDs work over such a wide range of voltage levels, wiring is usually done in a straight run or daisy chain. This means that the fixtures are all wired from a single run, with no need for multiple wire sizes or complex wiring layouts like T's, branches, or hub and spoke layouts. When would you need to consider using a larger gauge wire? There are 2 potential reasons for this: too many watts for the wire, and too much voltage drop on the run. A couple of simple charts can help avoid these problems and ensure you include enough of the right gauge wire in your plan and bill of materials. This chart lists the gauge of the wire, the maximum watt rating for the wire, and 80% of that, which is the maximum wattage that you should use on the wire. 12-gauge wire is the minimum gauge approved for landscape lighting use and the most common wire used in landscape lighting today. It's relatively inexpensive and will handle up to 192 watts on any run. You will need 2 runs at most on any 300-watt circuit. This chart identifies the voltage drop per 100 feet of wire based on the total watts used by the system. Voltage drop becomes a problem when it is so great that the voltage at the fixture is below the required voltage to activate the LEDs. So we need to pay attention to the conditions that could lead to a voltage lower than 9 watts at the fixture. What could cause this to happen? Let's suppose we have 6 13-watt accent lights totaling 78 watts at the end of a 250-foot long driveway. Our voltage at the transformer is 110 volts, and we measure the voltage at the 15-volt lug at 13.75 volts. Will 12-gauge wire be sufficient for this task? Consulting the chart, we see that the voltage drop per 100 feet of wire for 80 watts is about 2.13. Multiply this by 2.5 for 250 feet and determine that the total voltage drop over the run will be 5.33 volts. This means that the voltage at the end of the driveway will be 13.75 minus 5.33, which equals 8.42 volts. This is just below the range of acceptable voltage for Kichler LED fixtures, so we'll need a thicker wire. If we size up the wire to 10 gauge, the voltage drop at 80 watts would be 1.34 volts. Multiply this by 2.5 to get a 3.35 voltage drop over the run. To calculate that, the voltage at the end of the run would be 13.75 minus 3.35, which equals 10.4 volts, which is well within the LED fixture's range. As the example suggests, it takes a very long run with a significant number of fixtures on the end to require the installation of heavier gauge wire than the typical 12-gauge wire used in most installations. Now that you've created a plan, specified fixtures, and made any additional decisions about wire size, you are ready to create a bill of materials for the project. One of the great things about landscape lighting is that there are relatively few components. Here's a checklist to make sure you don't forget anything at the distributor. Fixtures, plus optional accessories like lenses, louvers, cowls, wall, or tree mount kits. Your transformer, photocell or other controls. Wire. You can step off the wire runs with the measuring wheel on site, or use a scale plan to determine how much wire you will need for the job. Wire nuts, 2 per fixture. Mounting supplies including stainless steel U-shaped staples, screws, zip ties, and any other mounting hardware. This completes the course on landscape lighting design, preparing you to get started in one of the most profitable landscape services in the industry. Good luck out there!